The basics of Java. Here we go. Wish me luck. Let's hope for the best. What we see here is a sample Java program. I want to talk first about the anatomy of a program. In full disclosure, what you're going to see over the next couple of minutes is going to be some hand waving because we're not going to describe all of this anatomy in full detail. Rather, I like to just tell people, look, here's your basic Java program. All your code really goes inside main. This other stuff, your public class, the name of the class, what is this static void main string args, all of that we can offload and postpone for later. But for now, the details are some of the details. You see here in yellow, it says public class, basic Java program. Every Java program needs to be inside a class. Now, what's a class? That's a fair question. A class is related to objects, which we'll cover in a bit, because this is really called object-oriented programming, this entire series. So we're going to cover that in a bit, and as I said, so now we see some hand waving, because I'm not going to go into more detail just yet of what is a class, but it's absolutely related to objects and the overall course here, object-oriented programming. But for now, just know that all Java programs are absolutely going to be inside a class. Also notice the word public in red on that very first line. Every Java file is allowed to have one public class. And later we're going to talk about the importance of this modifier public. More details. The name of the Java file, the file that has your code for the Java program, the name of that file must match the name here after public class. So in this example, we see basic Java program, pardon me. This code has to be found inside a Java file called basic Java program.java. So they have to match perfectly. What we find inside here now is our starting entry point to the program, our main method that will automatically get launched by the Java virtual machine when we execute our program. This is the main method, which is why I'm highlighting main there. The other stuff we see in red, the public, static, void, string args, hand waving. We're going to cover that in a bit. For now, all you need to know is that all code goes inside this main method. And method are like functions in Python. So if you're familiar with functions, well, this is your main Python starting function, which we normally call main, and we call that main function when we run our Python program, we make that initial call to this main function as our launching pad, if you will, our entry point into your Python program. Well, Java does this automatically for you. It'll automatically be called, as I mentioned, by the Java virtual machine. And we're going to be covering functions in more detail later. For now, all we need to know is our main code goes in here. Also, blocks of code. See, in Python, we have those logical sections or logical blocks of code, which are based or identified based off of their indentation, right? The more something is indented to the right, we know that that's a logical section. Code within a while loop, it's all indented underneath the while. Code in a for loop, it's all indented to the right. Well, in that same vein, Java, we can see these indented blocks if you have good style, but in Java, actually, and unfortunately, indentation is not required, which means how do we therefore identify logical blocks of code? We have to use these curly brackets. So you do see on this example, it's indented nicely because we want to have good style, but that indentation, unfortunately, is not required, which is why Python is so great in that regard. It forces us to have good style. Here, we indent, although it's not required, and Java, therefore, can only identify the logical blocks of code based off of the curly brackets. So you see here I have two curly brackets that are shown within this main method. And then also on the outer class, we have another set of curly brackets to encapsulate everything that is inside that outer class. So for the entirety of this series, the assumption is that we know Python, right? We know Python and we're trying to now transition into Java. So with that in mind, what do you think is the best way to learn Java from the perspective of a Python developer? Just start with what you know and see how can we translate that into Java. And we're going to do this in an incremental process. Start with small programs and move to slightly larger ones and slightly larger ones, looking at new ideas and new constructs and say, hey, here is a basic Python program, Java program. How do we, if we know that's their objective, and if we start from Python, how can we then translate that Python program into a Java one? We'll do this for basic programming. We'll do this for if-elses, for selections, for loops, for functions, methods, lists, and more. So here's our first one. Write a program to calculate the area of a circle. And always we're going to separate this into two phases, the problem-solving phase and then the implementation phase. We need to get a radius, whether we get it from the user or we type it directly into the code, which is what we're going to do at first, is to be discussed. We're going to then compute the area, you know the equation, pi r squared, and we're then going to print the result. So here is our Python code skeleton on the screen. And what we want to do, and I notice I still have my first fail. I got wish me luck still open the entire time. That is fantastic. That is great. That's why it's a stream. So here I should keep that up. Wish me luck that this actually works. That'll be great. So here's our first Python code skeleton that we want to now put in our Python code for this. Now all of us should be able to do this rather quickly. Here's the Python code. Set a radius to 10, for example. Calculate the area, just radius times 3.14159 value for pi, and then we're going to print the result. Okay. And notice here in the printing, I did not use formatted printing by design. If you have Honor, absolutely as a Python developer, you're not going to be using printing with this concatenation. We'll be using formatted printing. I get that, but I want to show a more direct translation to a Java code because we don't know Java formatted printing yet either. So let's just show how this code would translate to Java. So first thing, look at the code skeleton. Here's the Python code skeleton. Here's the Java code skeleton. The only difference is what? Here we have our main and we're calling main. Java, we don't need to call the main. It's automatically going to be done for us. We have our main method, and the main method, which is shown in red and bolded, is inside this class that we called compute area. So actually I have NetBeans open, so let's go make this new project. File, next, new project, next. Let's call this compute area. I'm actually going to call it compute area of a circle. And as has been discussed, we want to delete the package as well as the period. And so here we go. We get this basic program. Let's put in the same skeleton. So step one was what? Get our radius. Step two is calculate the area. Calculate the area. And then step three, print the results. So we want to get the area, calculate the area, and then display the results. Here's what we have in Java. Just showing you the solution directly because you couldn't have guessed this, right, if you didn't already know a bit of Java. And we want to identify what's different between what we see here and what we did in Python. Because here's Python, here's Java. What do we see that's different? I've highlighted it and shown it in red. So the first thing is the data type. Notice that before the variable radius, now we have int. Before the variable area, now we have double. Okay, so what are these things? Python is a dynamically typed language, which is super cool, makes Python it feels easy, right? So the type of the data being used and stored in a variable in Python is only determined at runtime. And it makes it feel easier that we as the developer don't need to worry about data type. But it's also slower when you want to determine the data type at runtime. Java is different. It's a statically typed language. The type of data that you're going to store inside a variable is going to be known before you execute your program. It's known at compile time, which has a consequence. You as the developer, you have to now specify the type of data that you want to be stored in that variable, which is why we had to say here, hey, what do I want inside radius? I think I want an integer. Well, then we need to specify that we want an int to be stored inside radius. Now for area, is area going to be an integer? You might say, well, yeah, I think so. Well, no, because realize that area, even if radius is an integer, we have an integer, which is 10, a radius, multiplied by 10 again, another radius. That's 100, still an integer. But pi, that's not an integer, right? That's a double. And so that's a floating point number, a real number. That can't be saved into an integer. And so what is area? It's going to be a different data type, double, which I'll explain briefly. So these are the data types that we recognize we need. The variable's data type is the kind of data that we want to store inside that variable. And in Java, when you declare a variable, you have to state its data type as well as the variable name. Now, Java gives us many data types for integers, gives us many basic data types for your standard types, your standard values that we'll need to store, whether that be integers, real numbers, characters, even Boolean values. So these basic data types, they're all generically called primitives. Your integers, your int, double, float, long, char, these are all primitive values. And we'll talk more about what primitive means, but suffice it to say, it's the most fundamental type of data that you can find in Java. And two example primitive data types that are given for numerical values are int and double, as you see here. Int, we use it to store an integer. Double, we use it to store a real number, aka in programming terminology or lingo, a floating point number. Now the memory used is interesting. An integer requires 4 bytes to store an integer. A double is double that, 8 bytes. But it's something we should be aware of. An integer is 4 bytes, a double is 8 bytes. What was the other change if I come back? The only other change on this program was when we printed. When we printed, instead of in Python just having print, the area is, now we have system.out.print, and I included the ln after print, and I'll show you why here. So when we print, in Python we have just a normal print statement. In Java, it turns out we have 2 types of print statements. We have print, and we have println, which stands for print line. That's really the only difference. In Java, if we print something, let me just do a little print statement here in Java really quickly. If I say hello on one line, and then on the next line, I do hello world, or sorry about that, let me just put just world here. Notice I did a print with an ln on both of these statements. That's called print line. It actually prints the word or the string hello, and it prints a new line afterwards. And so here we printed world with a new line afterwards. If I get rid of the ln, it does a print without making a new line. As we see here, all prints on the exact same line. That's the distinction. So more often than not, we'll be using print line in Java. So we simply went from this statement here in Python, the area is, and we had to concatenate the actual value in the variable area as a string that's required in Python. In Java, you don't even have to do that. We could just concatenate area. Java allows you to concatenate strings with numerical values. So the print statement was even pretty similar. So here's our first Java program. From this Python program to this Java program, not too bad. Let's code that up and run it so we can see it live. Let me control V here. And let's change this now. So we had int radius equals 10. We have double area equals radius times 3.14159. I hope you all are doing this with me. Absolutely important to see this work for yourself. System.out.println. You may have noticed I had a shortcut that is built into NetBeans that I typed. It was SOUT tab. It's a shortcut. Certainly very nice. SOUT tab. And here I'm going to print the area is, and I'm going to concatenate area. And let's give this a run, and certainly we get our answer. The area is that. I can come change the area, make it something else, make it 5, run it again. The area is 78.54. So here's our first program. Pretty straightforward, not too bad. But I would argue it's kind of boring. Why is it boring? There's no interaction with the user. We are directly typing in the value for radius instead of asking the user to enter the radius. What if we wanted to ask the user to enter the radius? Here's how our Python program would have changed. Instead of saying radius equals 10, we'll say radius equals, and we're going to use two functions in Python. The input function, which will scan from the user, and recall in Python, the input function, it scans everything on one line until the user hits enter. And then we use the int function, which then converts what the user entered into an integer. So of course we have some caveats here. We have to make sure the user will only enter a number, not multiple numbers. If we try to convert multiple numbers to an int, that would also cause an error. But that's what we're using. Our input function is our scanner in Python. It allows us to scan from the user. And then we converted that string input into an integer by using the int function. So how do we do this in Java? Java uses the scanner class to read input from the user. We have system.out, which we've seen already, right? System.out. This allows us to call the printline method. Methods and functions are synonymous. We call this printline method, which is inside the system class, or the system library, if you will. And system.out is the standard output device, referring to your monitor. System.in refers to your standard input device, your keyboard. So how do you read from the keyboard in Java? We use a scanner object. And in fact, we're going to make a scanner object. And here's the exact line of code. I'm going to put a comment first. Make a scanner. I'm going to capitalize that. Scanner object. Scanner in input equals new scanner system.in. Now we're going to get an error, and I'll get to that in just a moment, but that is the correct line of code. So this is the line of code, and let's talk about that. So firstly, the basics. Remember, this is an assignment statement, right? If you see an equal sign, that's not equals, as you know, that's an assignment. And we have an assignment statement, our eyes, we need to start on the right side of the code. So on the right side, what do we see? It says new scanner system.in. What's going on there? We'll learn more, but baby steps. What's happening? This is a command. We're saying, yo, Java, make a new scanner object and make it such that the scanner object is going to be reading from the keyboard. That's what happened. We made a scanner object. It's magic. And that object is going to be scanning from the keyboard. Now we look at the left side of the assignment statement. What does it say? It says take the reference of the scanner object and save it inside the variable input. Now, being this is Java, we have to specify what's the data type of input. And here we specify the data type of input is a scanner object. It's not an integer, right? So I couldn't say, hey, Java, make this new scanner object, save it into a variable of type input. Oh, by the way, input is a double. That doesn't make sense. Input's not a double. What are we saving inside the variable input? We're saving a scanner. Or more precisely, we're saving a reference to a scanner object. So this entire line, it creates the scanner object, and it saves a reference of that object into the variable called input. And now we can use this variable to begin scanning from the user. We can use this object to scan from the user. And in fact, there's many methods that we can invoke on this scanner object to help us scan. And I typed here, like, what do we mean by that? In Python, as you likely recall, I'll use strings as an example. Strings are objects in Python. And because they're objects, strings have many methods that can operate on those particular string objects. The example given, city equals New York. That's a string. If I print city dot upper, what is dot upper? It's a method. It's an actual string method in Python, and it operates on that particular string, in this case, New York. So what does upper do? It makes all characters of that string uppercase. Pretty simple, you already know that. But the purpose of reminding you of this, that in Python, we actually have methods as well. And these are methods that operate on specific objects. So in that same vein, we go back to Java and the scanner object. Well, now we have this scanner object. It's called input. Well, that input scanner object, it has methods that we can use to operate on it. Okay? So one of those methods, or many of them, will be used to scan data from the user. And here it just so happens we're going to use the nextInt method. This nextInt method is going to allow us to scan. It's really a command telling Java, yo Java, go to the user, have them input data, and keep scanning character by character by character until you see a space or an enter or any type of white space, and then consume that input and convert it into an integer. So notice we don't need an input and then we need a separate int function to convert it to an integer. It's automatically done in one go using nextInt. So now we can go ahead and add or make this change to use this particular method of the scanner object. So instead of saying int radius equals 5, we now need to actually prompt the user. So get radius from the user. So let's print to the user system.out.println. Enter an integer for radius. We're specifically asking them to enter an integer. And then we want to, on the next line, we want to scan. So how would we scan? If this were Python, we would have done this, right? We would have done that in Python. So in Java, we don't need to do the int, but we do need to still scan. So how are we going to do that? I'm going to move that to the side so you can see them at the same time. In Java, I'm going to say input dot nextInt. And we use parentheses because it is a method. So let me delete this. So what this does is it says, yo Java, go to that input object that we created, and call the nextInt method. Invoke that nextInt method on that scanner object, and then save the result into the variable radius. And this is now going to work. As mentioned this line above, there's an error, and I'm still going to come to that error. Let me go ahead and actually fix it now. So I could just come type it directly. What it needs is I need to make an import. Right now, Java is basically saying, I don't know what scanner is. Like, thank you so much, but I don't know what this is. What are you doing? We need to tell Java, hey, scanner, yeah, Java, you know what scanner is. It's actually in one of your other packages, in one of your other libraries. So we need to come and actually import it. Import java.util.star or .scanner if I want to import it directly. So now I'm saying, hey Java, go to the Java package, which is just a folder, go to the util package, another folder. Inside there, you're going to find what you need to understand scanner. And this again is the same vein as in Python, where you need to import things such as random, such as math, such as time, various libraries or modules in order to use the components within them. So now if we run this, let's check it out. Enter an integer for radius. Let's enter 10, and we get the exact same answer. But there's one thing I see I would want to change, because previously we had 10 on the exam. I'm sorry, we'd want to have 10 on the same line when we're actually asking the user to enter the input. I think it would be better if when they're entering, instead of entering on the line beneath this, we enter on the exact same line. So how can we change that? When we print, we don't want to go to the next line. And I told you in Java, there's two prints. We have print ln for print line, or we have just pret. So I'm going to get rid of the ln. And when I run this again, now I'm going to get enter an integer for radius, enter 10, and we get exactly what we want. So coming back here to the slides, this is the result. You notice I imported Java above, And briefly, let's talk about that. As I mentioned, we have to import scanner in order for Java to understand what scanner is. We have to actually import it. Even though it's part of Java, it's in a different package, and so we have to basically make that connection. And what is a package? As you know, a package is just a folder. And in this case, we're specifying, hey Java, go to the Java package, the Java folder. Inside that, go to the util folder. Inside that, look for what you need to make scanner work. And so we have to make that import before we do our other code, before we start coding the actual class. So we import that on line 1. Important to state is there's 2 types of imports. Here we did a direct import, if you will. I directly typed, I said, hey Java, within that util folder, go get scanner. Now what I could have done instead is simpler. I could have said this, it's called a wildcard import. What this says is, hey Java, whatever you think you need for this program, assuming it's found within the util folder, go grab it. So now Java is going to realize, hey, I need the scanner object. It's going to look inside here and it's going to look for the scanner object. You may not think that would be faster, but in fact, it's actually faster when you use a wildcard import. And we get the same result. What next? Compute average. So now with this in mind, we've shown you this one program where we've interacted with the user. We got a radius from the user. We then calculated the area of that circle, and then we printed the result. With that in mind, see if we can do on our own another very similar program. Compute the average of 3 numbers. Ask the user for 3 numbers, compute their average, and then print the result. Here, I went ahead to the Java code. I didn't want to jump ahead that fast. I thought there was something else. So before actually going to that, I'll wait 5 seconds. Try to do it on your own. You can hit the pause button. Try to code this on your own and see if you can. And then come hit the pause button and see if your solution matches up for what we're about to show. But first thing, since we need to get information from the user, we need to scan. Implementation phase, right, is coming next. We now need to first talk about, do we understand the problem solving phase? We need a scanner to scan from the user. We need to add all 3 of those numbers together after we get all 3 of them from the user. And then after we add them, we need to, of course, divide them by 3, since it's 3 numbers, and then get the result. Now notice I didn't say ask the user for 3 integers. Instead, I said just any 3 numbers. So let's code this one up. Make a new project. Next, let's call it average 3 numbers. Let's get rid of the package. Oh no. Let's try that again. Get rid of the package. There we go. Hit finish. And what I'm going to do is take this same code here as my starter code. I don't even want to complicate this, but notice when I do so, what just happened? The class, it's giving me an error. It says class compute area circle is public, and it should be in a file called compute area circle. Of course, what just happened is what? I have this class here, average 3 numbers, which is inside its file, average3numbers.java. But when I come over here and I delete this and I paste that code that I copied, I also pasted the class. So if you don't want to have to deal with renaming this yourself, you could just come over and instead of highlighting everything, you could say, let's highlight up till here. Just my main, don't forget your final curly bracket. Or just highlight just your main. Let's do that. Highlight just the main and then come here and we'll paste and we'll delete our previous main by hitting backspace and then paste. I don't actually, let me hit cancel on that for a moment. I don't actually have to even hit backspace. I can just highlight my main, and when I paste, it'll delete and paste, as you know. Now notice when I paste, Java automatically recognizes, hey, you're pasting a reference to a scanner. Would you like us to go ahead and import that for you? Kind of nice. Yeah, that's worthy of a celebration. Let's go. Thank you, Java. It's doing that for us. It's recognizing we needed something, and it's pasting that for us. Saves us time. We all love time savers. So what do we need to do in this program? We need to get 3 numbers from the user. So let's do this one at a time. Enter a number. And we're then going to save that number. So enter a number, and let's just call it num1. Now notice I didn't ask the user to enter an integer. So let's make sure that we're going to save this inside a double, the data type double, which can hold a real number in case the user enters 5.7, for example. You can't save that into an integer. So here I'm going to use next double. And you know what? Let me even pause that thought. I'm going to make a new project called garbage. A very important project you should be using as you're going through all of these programs. Whenever you just want to code something up quick and dirty, I do it right in here inside garbage. So here, because I just stated something that maybe we haven't covered clearly. So for clarity, if I say int x equals 5, that works. I can take 5 and save it inside x. But I can't actually say int x or int y equals 7.3. That won't work because this is a double, right? 7.3 is a double. That's 8 bytes of data. We can't save a double inside an integer. So that is problematic, which is why we want to go ahead and make this double num1. And notice I have input.next double. So I'm telling Java here, hey, use the scanner, that scanner variable input, that object we created, but this time do next double instead of next int. And we'll talk more about the scanner and the various methods it has. For now, we've seen next int, and now we've seen next double. And in fact, I want to do this 3 times, right? 3 different numbers. So paste and paste, but let's call this num2. And let's call this num3. Step 2, calculate the average of those 3 numbers. So what is average? Double AVG equals. How do we get the average of 3 numbers? People would normally say, well, take num1 plus num2 plus num3, divide all that by 3. Do we see the problem with that though? So from Java's perspective, there's no error there, but logically, I think everyone recognizes what's happening mathematically here is we're only dividing num3 by 3, and then we're taking the result of that and we're adding it to it, num2, and we're adding to that num1. That's not what we want for average of 3 numbers, right? So we want to actually divide all of them by 3. So we need to put them in parentheses, which is what you would have done on a calculator as well. So we determine our average and then print the result. So I can say the average is AVG. And let's give this a go and see if it works. Enter a number, 5. Enter a number, 3. That's going to be 8. Let's do, what's the average of, how about 24, right? What? 24 divided by 3 is 8. So let's add to this 16. Did I do that right? 5 plus 3 is 8, plus 16 is 24. 24 divided by 3 is 8. We should get 8 as our answer. That was way too complicated for me. Should not have taken that long. The average is 8. So now we can put other numbers. 1. How about we put 2.8? Oops. 8.9. Let's do this. 1, 2, and 8.9. The average is this. So here's our code. Perhaps that matched up with the way you did it. Perhaps you did a little bit differently. That's perfectly fine. There's many ways to code the same problem. So here is our solution. Notice we have, this time, I used double and I used next double, right? As our data type is already explained. The only other thing that I did here differently is instead of calling the scanner variable input, I went ahead and I defaulted to my personal preference. I call the scanner input variable in. I prefer not using input. I just prefer in. It's quicker. You could frankly call it Bob. You could call it W. It's just a variable, right? So on this solution here, I called it in, and I want to do the same here as well. So I'm going to change this to in, and in. I copy, pasted in, and I copied it and I pasted it 3 times. But I want to show you how I could have done that faster. I want to rename this one variable. Notice when I highlight this variable input, it goes ahead and highlights it on line 11, 13, and 15. So now if I hit Control R and I just type IN, I'm guessing this would be Command R on a Mac, and then I hit Enter, it renamed them all for me in one go, which was super cool. But again, it's just a variable name. I could have called this Bob. My scanner, you just want to name your scanner Bob? Perfectly fine. It's going to work just fine. 5, 4, 5, and 7.8. There's your average. So let's go ahead and let me hit stop. And let me rename my scanner one more time to N. And let's pick back up. So here's some runs of the program. On the example here, I didn't ask the user 3 times. I just asked the user 1 time. It's perfectly fine. We'll talk more about the scanner and how it's scanning and working. So some small details of the language. What's an identifier? What's a literal? We'll talk about these things. What's an identifier? Identifiers are names that identify elements of your program. We're talking about classes, variables, the names of methods. So a variable is an identifier. The name of your class is an identifier. The name of your method is an identifier. And every language has rules that stipulate which characters can make up an identifier. Java is no different. Java, an identifier, is a sequence of characters that consists of letters, digits, underscores, or dollar signs. Kind of weird. Dollar signs, right? So letters, digits, underscores, or dollar sign. An identifier must start with a letter, an underscore, or a dollar sign. It cannot start with a digit. An identifier also cannot be a reserved word, a keyword that you're going to be using for your Java program. An identifier cannot be true, false, or null. And finally, an identifier can be of any length. So some valid identifiers, the word area, radius, those are variables, they're valid identifiers. Compute area was the name of our class. That was a valid identifier. Even $2, believe it or not, it's a valid identifier. Here are 2 illegal identifiers. 2A, the capital A. Not because of the capital A, but it started with a 2. It's not allowed in Java. Or D+4. That's not a valid legal identifier because plus signs are not allowed. Notice that you could use underscores. For most of the time, that's also not going to be something we're going to want to do in Java, and we'll talk more about that when we get to the style of Java. Finally, Java's case sensitive. So we have area written 3 ways here, where just the first A is capitalized, where it's fully lowercase, fully uppercased. Those are all 3 different identifiers. So next we talk about declaring variables, initializing variables, and how we do this. We can declare variables as you see here. I'm going to come back to my Python, to my garbage program, declare, comment, declare variables. So int x, that's a variable. Int y, that's another variable. We've declared them. And I'm telling Java, let's make another one. Double z. I'm telling Java, yo, I got this variable z. It's going to be a double. I haven't saved anything in it yet, but it's going to be a double whenever I'm ready to save stuff into it. That's how you declare variables. Pretty straightforward. After you've declared the variable, I could then say x equals 5. On the next line, I could say, you know what? X equals 8. I changed my mind. Because it is in fact a variable, we can change its value. Notice, however, I cannot say x equals 5 and then later say int x equals 8. Because when I say int x, at this point, at that moment in time, I'm telling Java, yo, Java, I got this variable x, and it's going to be an integer. Just heads up. And we're going to save stuff inside it, which we did right here in line 11. We saved a 5 inside that integer x. So on line 13, if I say, yo, Java, I got this variable x, it's an integer. Java's like, dude, you already told me you have a variable x that's an integer. Have you lost your mind? Java says. And so it gives you an error. And if we go read that error, it says variable x is already defined. There's no reason to define it one more time or to declare it one more time. So we declare our variables, and then afterwards we could set values to them. I could say z equals 4.9, x equals 4, and then I can, of course, change them to 111.2 for z. I could change x to be equal to 12. They're variables, right? You can change them. So here we had declarations, and here we had the initializations separately. We can also declare and initialize in one go. I can say x equals 5. I can then say int y equals 4. Let's make it 3. Double z equals 70 equals 77.49. Weird, but it works. So we can declare and initialize those variables in one go. Also notice that we can declare and initialize many variables all on one line, as you see here. Int I is 62, j is 78, k is 35. That's allowed because it's the same data type. So if I have int and they're all the same data type, we can do that in one step, and it makes it a bit easier for you. Everyone should know assignment statements. After we create a variable, we can assign values. Into those variables. And so here are some examples where we're assigning 1 into y. We assign 3.0 into w. We can assign the result of an expression into x, or radius times pi. We can assign that result into area. Pretty straightforward. Something also unique, let me do this. Int ABC. I've declared 3 variables, and now assign the value, let's say 8, to all 3 variables. I could do this. I could say A equals 8, B equals 8, C equals 8, no harm, no foul. But recognize and remember that assignment, where do we start? Our eyes should go where? To the right side. So when I come to this right side and I see this 8, I'm going to assign it or save it into the variable C. So therefore, check this out. I could say A equals B equals C equals 8, and that's funky, but it works because we're taking 8, we're assigning that value into C, which is now 8, and we're going to take that value and assign it into B, which is now going to be 8, and we're going to assign that value into A, which will now also be 8. Kind of cool. Something else we've seen before, just worth the reminder, that given a variable, int x equals 5, we can, let's say we want to increment x by one value, by 1. I could say x equals x plus 1. You know that from Python. And what does this do in Java? We can use the same variable on the right side of the assignment, as you know, because this x right here is really 5. 5 plus 1 is 6. 6 then gets saved into x. Nothing new there, but reminders are helpful. Yes, I'm trying to see, we've covered this earlier, that we cannot, of course, save into x 1.0, because 1.0, by virtue of having this decimal value here, this 1.0 has now become a floating point value, a double. So if I say save 1 into x, what is happening here? This here is an integer, and we're saying save that integer into the variable x, which is also an integer. Good deal. But if I say 1.0, well, this is no longer an integer. This is a double. And this is now saying save that double into x. Okay, I'll work with you, Java says, but whoa! You're telling me to save it into an x, which is an integer? I can't do that. So you got to get rid of this 1.0. And we'll get to typecasting later in case we wanted to cast the right side of this assignment into a smaller data type into the right side. So named constants. This is something unique for Python, that Python does not allow or does not have constants. You might think, wait, I had constants in Python. My instructor, maybe your instructor, said if you, instead of having pi equals 3.14159, instead of doing that, your instructor may have said, make it capitalized, make capital PI equals 3.14159. And by capitalizing the variable, it serves as like an identifier for the reader and other developers to know that you're intending this to not change. You're intending it to be as a constant. But in fact, Python does not have constants. Any variable, hence the name, can be changed. But in Java, if I say double pi equals 3.14159, does pi change? Absolutely not. So we want it to be a constant. So how do we make it a constant? We type the word final beforehand. And when I type that keyword final before the data type double, I am now unable. I cannot say pi equals 8 later in the program. It won't let me, right? If I get rid of the word final, this variable pi is just a variable. I can change it to 8. I can change it afterwards to 12, no issue, to 12.9, no issue. But when I type the word final right here, that's saying, Java, don't allow me, anyone else, to change this value of pi because it is in fact a constant. That's the first thing. And the second thing, as far as a style, constants should always be capitalized because yes, it does serve as an indicator to the reader that, hey, this thing is capitalized. Why? Oh, because it is in fact a constant. So this is constants. So what I've done here, just a small change, is I went back to that compute area program, area of the circle, and I said, you know what? Since we're using this here, 3.14159, and now we know constants, let's come up here and make that. Final double pi equals this. And so now here, I can use that in my program. Cool. That is easy. Make sure you'll hit pause. I'm looking, this is a 45-minute video. This takes time to consume all of this. Hit pause so you can go through this and I feel a bit more comfortable about it. So those are constants, that's the value. Some style guidelines. In Java, there's some styles that we want to follow. You don't have to follow them, but when you're working with a team, other developers, you need to fall in line and make sure you follow the correct styles. So the first thing, you see this picture of a camel here, which is kind of funky, but why do I put that? Because the style for variables in Java is called camel case, which is kind of weird, right? Camel case. What does that mean? Well, you see this hump on the camel, and you see that word, camel case. So if you have a variable that is comprised of 2 or more words, those words should be concatenated together, glued together, and the first letter of every word should be capitalized except the first word. So if you look here, this variable first name, the N is capitalized. Last name, N capitalized. Date of birth, 3 words. Therefore, the O for in of and the B in birth are both capitalized. More style guidelines. Class names are not camel case. Class names, when they're comprised of 2 or more words, every first letter should be capitalized. Constants should be fully capitalized. Some more stuff. Numerical data types. This one is the next like 5 or 6 slides. We're going to talk about the various type of data types in Java, their sizes, things you need to know. Honestly, it's not exciting, but it's things that are all important. So every data type has a range of values that data type can hold. And you need to understand these range of values and understand these primitive data types. Java has 8 primitive data types, and this table on the next page will show you 6 of those numeric primitive data types. We have byte, short, int, long, float, double. Until now, you've seen me only using int and double, and truthfully, it's the main ones we're going to use. We're rarely going to be needing to use long. The only reason someone would usually use float is if they want a real number but are really stressed on space and they want less space for their programs. But usually int and double will be more than sufficient for us. So notice this range of values for int. The range of values, the smallest possible value you can save into an int is actually minus 2 to the 31. And the greatest value that you can save inside an integer is 2 raised to the 31st power minus 1. If you actually took out a calculator, you would get this exact number right here. Let me actually make an int with that value. So int x equals 748. I do not have this memorized. 3647. 3647. Cool. So now, what if I do this? I'm going to print x, and then here I want to print x plus, oh no, I want to print x, and then I want to update x. X equals x plus 1. And then here I want to print x again and see what we get. You might be thinking that we're going to get, oh, just take this number, add 1 to it. This will be an 8. Or let me add not 1 to it, let me add 2 to it. This 7 should be a 9, you may think. Nope, it is not. How do you add 1 to this number and get a negative number? Like, this makes no damn sense at all. What's going on there? What's going on is that we have exceeded the range of an integer. You cannot store a value bigger than that inside an integer. In fact, check this out. If I try to make that an 8, just manually, I'll say, you know what, not a 7. Let's put an 8 right there. You literally cannot save an 8 into that integer. It's too large. It doesn't fit. And if you recall, again, an int is, I'm going to put here in comments, an int is 4 bytes. 1 byte, as you know, is 8 bits, right? And so now we have a total of 32 bits of data, where every bit can be 1 or 0. And if you look at what can fit, if you make all of them 1, the last bit is for the sign, meaning plus or minus. But if you make all of the others 1, that's the biggest possible number. You can't fit more information, which is why we get an error. And it actually says the integer number is too large. So the biggest we can have here is this number right here. The biggest double is this one. It's a pretty big number. Shouldn't be causing us too many issues. So let's see. We covered all of this. Number literals. The word literal, don't be confused by it. It just means the value that you're going to save inside I on this example. So int I is 34. What is the literal? It's 34. Long x equals, what is that, 1,000,000? The 1,000,000 is the actual literal. It's important to know what that word literal means because you're going to hear it more maybe over the semester, maybe in a book, maybe online. It's important to know what that means. And also because we talk about what kind of literal can be saved into what kind of variable based off of its data type. So for example, if you look at this statement, byte b equals 1,000, that will give you an error because on the previous slide on that table above, we saw that a byte, the biggest a single byte can be is 127. So you can't save 1,000 into it. That would cause an error. You cannot save more than what can fit. The literal that you're using, the biggest literal for a byte would be 127. We have covered all of that. Floating point literals, we've seen that we have floats and we have doubles. Floats themselves are, again, not going to be as common. It's just a smaller sized double, if you will. Less precise, less precision, not as valuable. But you can use floats in Java, and you can read more about that online. Here's a page talking about the distinction between what is a float, what is a double, and it goes over that in more detail. Numeric operators. This should be super easy, right? We know how to add, subtract, divide. We should get excited. Yes, give me one. I gotta get excited. Yeah, let's go. We have numeric operators. It's going to be super easy, except for when I then come to remainders and I say mod, then all of a sudden some of you start crying, cursing. We remember mod, and mod can be a challenge if you don't understand it. But no, mod is easy. What is mod? Mod's just a remainder that we learned in like 2nd or 3rd grade, right? Mod, if you simply look at this example in the bottom left, 15 divided by 2. What's the answer? The answer is 7 with the remainder of 1. Therefore, 15 mod 2 is just 1. That's just pretty straightforward. So hopefully you remember from Python, we have integer division. We also have traditional division, right? Here's our normal division, 7 divided by 2. We expect 3.5 on a calculator, right? But when we think in programming, 7 divided by 2, we may think, oh, that's going to be 3 with a remainder of 1. Or maybe 12 divided by 5 is going to be 2 with a remainder of 2 as well, right? So what are we thinking about integer division or traditional division? We recall in Python, we have 2 divides operators in Python, right? Python has 2 divides operators. We have a single forward slash as well as a double forward slash. And the distinction is that the single forward slash was traditional division, whereas the double forward slash would give you integer division. And we're going to show you how Java makes this, how Java distinguishes between those as well. So remainder, you likely recall, remainder is useful, right? When you want to go check if numbers are even or odd, if you want to check a variety of different things. So there's so many values for remainder. Here's a simple problem. Convert time. Ask the user for the number of seconds, and then convert this number of seconds into minutes and then into remaining seconds. So the first thing, problem solving phase. We want to ask the user, let's make a new program first of all. File, new project. And I hope you're making this exact same project with me. Let's call this, what do I want to call this? Convert time. Why not? There could be a better name, but I'm going to keep it simple right now. Convert time. So here, when we do this, what's the first thing? I'm going to take my code from a previous program. I'm going to take the entire main and I'm going to come copy it, make my life easier. Done. It's going to say, hey, you need to import your scanner. No problem. Done. I don't need pi. I can get rid of that. Here, I'm not going to get the radius from the user. I'm going to get seconds from the user. Enter an integer for seconds. I'll just say enter the number of seconds. Done. I have the seconds. I'm going to save it. Int seconds equals input.nextInt. Calculate the number of minutes and the number of seconds. Or let's call it remaining seconds. And I'll explain what I mean by this. I didn't really cover that yet. So I need to make some calculations, and then I need to print the results. So for clarity, if the user enters 120 seconds, what is that? That's 2 minutes and 0 seconds, right? If the user enters 150 seconds, that's 2 minutes and 30 seconds. Yeah, okay, think about that. So if they enter 150 seconds, how'd you get that it was 2 whole minutes? You know the answer. You divided it by 60. And then how'd you know it was 30 remaining seconds? Well, that's the remainder of that division. So if we take 150 and we divide it by 60, that will give us 2 minutes. And then we have a remainder of 30 seconds. So how do you get the remainder? As you know, in programming, that's mod. So in fact, if I had said 150 mod 60, do that same calculation, divided by 60, but instead of telling me 2, the result, tell me the remainder, which was going to be 30 seconds. So with that in mind, perform these calculations. Here I'm going to simply say int minutes equals seconds divided by 60. Int seconds, how about seconds remaining? Seconds remaining equals minutes divided by, or minutes mod 60. And this should give us exactly what we're looking for. I now have my minutes and my seconds remaining, and then I can print the result. I'll say seconds. This is going to look weird. Seconds is the same as, oops, that should be seconds. This many seconds is the same as minutes and seconds remaining. This is getting ugly. Seconds. Did I type that all right? Let's see. No, I didn't. Wait. We have variable concatenation string concatenation. I forgot a concatenation. You're probably shouting at the screen. You saw it as well. So this is why doing formatted printing so much better, so much more honorable. We have this horribly long line. I could have made this with any of these concatenations in Java. When we're concatenating, I can take any one of these points and just hit enter to go to the next line if I want to make it spaced out better. No problem, it's the same thing, but it just looks ugly anyway. But let's check if we did this right. So if I enter 150 seconds, that's the same as 2 minutes and 2 seconds? No, it is absolutely not. What do I need to make sure I print here? So seconds remaining is not minutes divided by 60. Something else you probably shouted at the screen. It's the original seconds divided by 60, right? We wanted to perform, we said the exact same equation, calculation. 2 minutes and 30 seconds. Let's do another one. 840 seconds is equivalent to 14 minutes and 0 seconds. That wasn't exciting. What is 10 minutes? 10 minutes, 60 seconds. That's going to be 600 minutes, 600 seconds, right? 10 minutes, 60 seconds, 600 seconds. Let's do 613. It should be 10 minutes and 13 seconds. Sure enough, boom. That was easy, worked. So here's our algorithm, and here is the result that we have on the slides. Should be pretty similar to what we just coded live together. An important point, this is kind of funky. So it's just the idea of knowing how floating point numbers are ultimately saved on a computer and the lack of precision. And if you do this in Python or any language, you're going to see the same result. What if I say print 1.0 minus 0.1 minus 0.1 minus 0.1 minus 0.1 minus 0.1. You would expect that would print 0.5 because in fact anyone can do that calculation. We subtracted 0.15 times. That will give us 0.5. But when we run it, like, oh no, what is going on? This has to do with the limited amount of space, 8 bytes, that data is stored in. And so it's just not going to be correct. And so you need to be aware, and this will be true if you did the exact same thing in Python, you need to be aware of the lack of precision when it comes to floating point numbers. This slide, not a lot to say, just to tell you that we can do math.pow, and it will give us, we can perform exponent operations. Super simple. So math.pow, how about we do 2, 3. And then I run this code, and notice that I did not have to import math to make this happen. That particular library was already available to us. We did not have to actually import math. So just math.pow 2, 3, it gives us 2 raised to the 3. You want to do 5 cubed, no problem, 5 raised to the 3. You want to do, let's do one more, 5 to the 8, a much larger number. I have no idea what that is. There we go. Not very exciting, but something to be aware of. So this one I'm not going to code up because I see this video is getting long here, but a simple one. We want to convert one temperature, Fahrenheit, into Celsius. Here's the equation. Pretty straightforward. I would say go solve this right now. Ask the user to enter the Fahrenheit. Use this equation to determine the Celsius, and then print it and see what happens. You should all be able to come up with the overall code because it's the exact same skeleton of any one of these. Ask the user instead of a radius, ask them for a temperature in Fahrenheit. Perform the calculation, print the result, and see what you come up with. Because when we see that, I hope you hit the pause video and I hope you're back now. Because when we do that and we see the result, this is what most of us should have come up with. Pretty straightforward. But it's going to be wrong. And why is it going to be wrong? In fact, if you enter 212 boiling in Fahrenheit, which is 100 in Celsius, this will print 0. Why is it printing 0? Right? Why? I mean, and why? Because here's the calculation right here. Why is this printing 0 for this calculation? That's just weird. It doesn't make sense. Well, the reason has to do with division in Java. Because notice we have here 5 divided by 9. And as I told you, in Python, we had 2 divisions. We had 5, we could do 1/9 or 2/9. That distinguished between traditional floating point division and then integer division. But now in Java, we only have 1/. There's no 2//, there's 1. So what does that 1// actually do? Let's take a look at that. This was a reminder for Python. So here, because what's going on is this 5 divided by 9, it's actually evaluating to 0. I'm going to come back to my Java, my garbage project, and let's print. Let's print some things. Let's say 5 divided by 9. So try to figure out what's going on. What's going on there is it's going to print 0. And we want to understand why is it actually printing 0, because that's kind of weird, right? So because Java only has a single division operator, which I prefer, it's easier this way. Well, now Java at runtime or at compile time, it's going to be determining what kind of division needs to take place here. Is it going to perform integer division, or is it going to perform traditional floating point division? So what Java does is it looks at both operands. It looks to the left of the divides and it looks to the right. If both of them are integers, it's going to perform integer division. And if I ask you, how many times does 9 go into 5? The answer is 0. Java prints the correct answer. 9 goes into 5 0 times. So if you say, well, I don't want integer division, I want like real division, traditional division, no problem. You need to make one of these numbers, either one or both, but only one is needed. Make either one of them something other than an integer. So make this 5.0. It's that simple. When we make that 5.0, now we have a double divided by an integer, the result of which will now be an integer. Hope that's clear. If not, rewind it, listen again, and then ask if there's any questions. So the only change we needed there was to make that a 5.0, and now it works perfectly fine. Super cool. Increment and decrement. Let's go. Increment and decrement. Yes. Int x equals, how about 5? Int y equals 3. Let's do some things here. Let's stick with just 5. Int x is 5. It is so common, as you already know, to do this operation over and over, whether it be while loops, for loops. We need to always update x, increment it by 1. As a result, Java, instead of forcing you to do this, just adding 1 to it, Java's like, well, if you just want to add 1, no problem. Do that. X++. That increments x. X is now going to be 6. So I can print x, and x is now going to be 6. This is an increment operation. In fact, you can put the plus plus after the x, or you can put the plus plus before the x. So now x got incremented twice, and now x will be 7. So here we have the increment operator is a plus plus. We have a decrement operator, which is minus minus. And here you can see the example on that slide. So it's literally pronounced I plus plus, I minus minus, and these are the increment and the decrement operators. We have a distinction though. We have what is called post-increment and post-decrement, as well as pre-increment and pre-decrement. We can put, as I said, this increment operator, we can put it after the variable, or we can put it before the variable. Now, if the only thing we're doing on a single line is incrementing, for example, then it doesn't matter. In fact, whether I did a post increment here or I did a pre-increment where I increment before the variable x, either way it's incrementing and we get the value, the output 6 and then 7. But what if we're doing other things? Because we can put the pre-increment and the pre-decrement, we can put them before the variables. So how does this change things? Consider the following. I'm going to skip this, but let me just explain here first. So where was I? So if the statement, as I said, is only doing increment or decrement, the effect of doing an I plus plus or an I minus or X plus plus or plus plus X, it's the same if that's the only thing happening on a single line. But that effect changes when you're doing other things on the exact same line. Let me just blow your mind and show you this. So if I wanted to do the following, if I said X plus plus, and then I want to print X, we expect this to be 6. Absolutely it is. What if I did this? What's going to happen here? We're going to print X, which is 5, and then after we print X, after it gets printed, we do the increment because it's called a post increment. The incrementing is happening in post after we print. And in fact, let me come print this again, just print X. So now when I print X, this print statement on line 11, we're going to see that X is in fact 6. But when I printed it here, X printed as 5 because it is a post increment. Had I done this, however, had I incremented first, which is called a pre-increment, what this does is it says, hey, increment X, make it 6, then print it, which we did. We're going to print and get a 6, and we're going to print it again and get a 6 here as well. It's kind of funky. Let me show you a really funky one. Int X equals 5, int Y equals what? Let's do 8. Y equals 8. And I didn't actually type on this example any decrements either, so check this out. Int Z equals, this is going to hurt, but plus X plus a what? A Y minus minus. And then let's print X is X, and let's print Y is Y, and then one more, let's print Z is Z. And let's see what we get. X is 6, Y is 7, Z is 14, and many of you are like, what just happened? First of all, let me explain. This line of code is trash, and you should never do code like that, ever. It's convoluted, right? You don't want to increment X in the middle of a line, especially with a pre-increment. Complete trash. But you should understand, as a developer, how it works in case you have someone on your team who's doing trash code. So first we'll understand it, and then we'll go shout at them and say, hey, that code is trash. Don't do it that way. It's horrible software engineering. But let's understand what's going on. Here, we're trying to save something into Z. So we look at this assignment. We start on the right side, and we say, what do we want to save into Z? We want to save the increment of whatever X is. So X is 5. We're going to do a pre-increment. So we're going to increment X to 6. And so we're going to save this value 6. We're going to take 6 and we're going to add it to something. But also we've incremented X. So X does become 6, as you see. But I just want you to see that what's going to happen here is that this all becomes 6 for the purpose of what gets saved inside Z. And then what are we going to add to 6? We're going to add this. But what is that going to be? Well, make no doubt about it. Y gets decremented. Y was 8. You can see the output. Y becomes 17. But this is a post decrement, which means that the decrement only happens after you perform this operation right here. So in fact, for the purpose of calculating Z and performing this operation, Y is still 8. And the decrement happens after we perform the operation, which is why we have 6 plus 8. Super funky. No lie. Super funky. Don't do this. Not cool. It's trash, but you should understand it. All right. That's what all this is. That's what this is in the slides. Go through it. Make sure you understand it. Make sure you know it's trash. Anyone who does it, tell them they're trash. No, don't do that. Don't tell them they're trash. That would be horrible. Numeric type conversions, we are almost done. I'm looking at the time here. Can you perform binary operations with operands of different data types? You're like, what the heck did you just say? Can you add an integer and a double? Of course you can. There's nothing wrong with that. I can absolutely say, let me just print, I can say no problem, print 2 plus 4.7. And it's going to print 6 plus 7, no harm, no foul. Or better yet, if I want to say double, x equals 4 plus 5.3. And then I want to print x. No problem, it'll print 9.3 as expected. No issue. We can absolutely perform a binary, which is like a binary operation, an operation involving two operands. We can perform that operation using different data types. Absolutely no harm, no foul. Okay? Also, we can always assign a value of a numeric variable just as long as the literal that we're saving fits within the range, and we mentioned this earlier. So here I can save a 4 into x. And then, of course, because 4 is an int, x was declared as an int. I can then declare y, and I can save x into y. Why? Why am I allowed to do that? Because x is an integer, it's 4 bytes. Y is a double, 8 bytes. I can save 4 into 8, right? No harm, no foul. I can absolutely int x equals, let's call x equals 3 double y. I can absolutely say y equals x. I can take that 3 and save it into y. And now if I print x and I print y, I want you to recognize something though. When I print x, what is x? X is 3. But what is y going to be right now? It's going to be 3.0 because it's a double. I didn't tell it to be 3.0, but that's how it gets stored because it is a double. Now, here we saw x can fit into y easily, right? But can the reverse happen? Could we have said y equals, let me get rid of this. Can I say y on this line above, pardon me, y equals, let's call it, I don't know, 9.32. Can I then take y and save it into x? Can I assign this 9.32 into x? Absolutely not. We're trying to take 8 bytes and save it inside 4 bytes. Ain't gonna happen. You're gonna have some major issues. That will not work. It will cause an error unless you use casting. So casting, as you know from Python, is a way of saving one data type into another data type. If we cast a type with a small range into a larger range, that is called widening the type. And that's what happened really here on this example. We widened 4 into 4.0. We widened the int into a double. We can also narrow a type with explicit casting, going from a larger range into a smaller range, but we would need explicit casting for that. So as an example, if I wanted to make this happen, I could have said this. And what that's going to do, and check this out, when I run it, I don't need to print x. I'll print x and y. So what is y? Y is 9.32. This says, hey Java, make y an integer. Well, how do you make 9.32 an integer? It cuts off the 0.32. It truncates it. And so now x is just going to be the 9. And the 9.3, of course, is still our y right here. So here we had to explicitly cast this larger data type y, which was a double with 8 bytes, into an integer of only 4 bytes. That is our numeric type conversions, and we're ending with conversion rules. So when we're converting, or when we're performing a binary operation, going back to division, when we want to perform a binary operation involving two operands, right? Java will automatically convert the operand based on the following rules. If one of those two operands is a double, Java will make the entire thing a double, and the other operand gets converted to a double. Else if, it's like a branching operation. Else if one of the operands is a float, Java makes the other one a float. Else if one of them is a long, Java will make the other one a long. Else if one of both of them will therefore be treated as integers. I skipped over these 2 pages. I don't think there was anything else here. Just telling you, of course, heads up. It was just mentioning the same thing as far as printing. If I divide 1 divided by 2, just like 5 divided by 9, that will give you a 0. Don't expect to see half, like 0.5 right there, unless you made this a 1.0. Then we're going to see 0.5. Or if I had, I'm going to go back to 0. So how do I get the 0.5 again? If I had done this. I'm saying, hey, Java, make 1 as a double, and now this will also become, the 2 will also become a double, and a double divided by double is, of course, going to then be a double. Hour and 20 minutes. This is a long video, but this means that we're going to be able to use more effective time with active learning. Reach out, ask questions, message as you need anything. It has absolutely been fun. We're done. Let's go.